Good morning, everybody. Today, I can solve polynomial equations with irrational and imaginary solutions using factoring, the quadratic formula, and isolate square root. So this builds on a lesson that we did a few weeks ago. We did polynomial equations with rational solutions, where everything was factorable. Today, we're going to incorporate factoring and then end up using the quadratic formula or the isolate square root method. And of course, we also learned completing the square, which would be an option as well, but that's probably the least focus that I want to talk about today. So Mr. X cubed, Mr. X squared, same story, same procedure for a polynomial equation. He wants to party. He can't party right now because not all of his friends are over. So we're going to subtract 4x from both sides. And again, the first step in a polynomial equation is to bring everything to one side. Party time. What do they want to do at the party? Bubbles. Bubbles mathematically means factor. Now we switch into factoring mode. What's the first thing we look for when we're factoring? GCF. Is there a GCF? Yes. Because it's a variable GCF, we have to keep it out front. Can I factor any further? Are there two numbers that multiply to 4 and subtract to 2? No. So we set each factor equal to 0, we set x equal to 0, and we set x squared plus 2x minus 4 equal to 0. Now, to solve this, since it doesn't factor, if the bulb machine's broken, I have to use my quadratic formula. So, a is 1, b is 2, c is negative 4. So, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 4 all over 2 times 1. Next, I go to my calculator. I type in what's inside the radical. So let's get my calculator pulled up. There it is. I got two of them. I don't want two of them. So I'm going to type in what's inside the radical. I don't type the radical in, just what's inside the radical. Oops. Button didn't press. 2 squared minus 4 times 1 times negative 4. I got 20. And now most students are great up until this point, and then mistakes are made. So the next step is to reduce the radical off to the side. So I don't have a lot of space to work with here. Let's go in the top corner. I need to break it down into my perfect squares and my non-perfect squares. 4 and 5 to radical 5. If you're not comfortable with that, then watch the imaginary numbers lesson where we go over reducing radicals. So now I'm going to replace the rad 20 with 2 rad 5. My final step, I want to take something out of all three. If I can, I do my little triangle. If it doesn't go into all three, I can't do anything. So I end up with negative 1 plus or minus 1 radical 5, which is just radical 5 over 1. I don't have to put the over 1. That and that are my answers. Whatever the highest exponent is, that's how many answers you're going to have. So that's how you can kind of check and make sure you didn't miss anything. And negative 1 plus or minus radical 5 is two separate answers. It's negative 1 plus rad 5 and negative 1 minus rad 5. And that's it. Let's skip ahead. And by the way, I could have done completing the square instead of quadratic formula, but you know, for consistency, completing the square can be really challenging depending on the example. Quadratic formula is always the same, so I would rather you just always do quadratic formula unless you know when to use completing the square and you're comfortable with it. In that case, whatever you want to do is fine. Let's skip ahead to number I don't know, let's take a look at 6. Mr. X cubed, he wants to party. Can he party right now? Nope. He needs his friends to come over. I'm going to add 18x, subtract 21 from both sides. I get 2x cubed minus 3x squared plus 18x minus 21 equals 0. Party time. What do they want to do at the party? Bubbles. Now, if there's x cubed or higher, it's going to have to factor. We can only use quadratic formula when there's an x squared. Now, once I pull something out, I might end up with an x squared, but if there's an exponent higher than 2, it's going to have to factor. Since there's 4 terms, this must be grouping. So my GCF of my first group is x squared. The GCF of my second group, what goes into 18 and 21? 3, I guess, right? Something's not right here. Let me pause this for a second. Okay, yeah, I remember. There's a typo in this one. So please change the 21 to a 27. My mistake. So the GCF would be 9. Positive 9. So I get x squared, 2x minus 3 plus 9, 2x minus 3. And then I combine my coefficients. I get x squared plus 9, 2x minus 3 equals 0. Can I factor further? Well, x squared plus 9, it might look a little bit like dots, but it's not. It's sots. It's not subtraction, so it's not dots. Not GCF, not dots, not trinomial, not grouping. It can't be factored further. So I'm going to set each factor equal to 0. I'm going to set x squared plus 9 equal to 0. I'm going to set 2x minus 3 equal to 0. Now I'm going to solve each of them. Now for the x squared plus 9 equals 0, you have a couple of options, but your best option when you just have x squared and an integer is to do your isolate square root. Isolate square root. When you take the square root, it's plus or minus. Now radical negative 9, the negative comes outside and becomes an I. Rad 9 is 3, so I get plus or minus 3i. For the other factor, 2x minus 3 equals 0. This one's linear, so it's pretty straightforward. We get 3/2. So again, since there was an exponent of 3, I know there had to be 3 answers. So plus or minus 3i are 2 answers, 3/2 is the other. And again, make sure you're comfortable with this isolate square root method. It's pretty simple. We did this also in the imaginary numbers lesson on the back, so you can refer back to that to practice it. But if you ever just have x squared and a number without an x term, you can just isolate square root. You could also use quadratic formula where b would be 0, or completing the square where b would be 0, but isolate square root is the easiest way to solve one of these. So let's just see what else we can go over here. I definitely want to go over number 8, so let's take a look at number 8. Mr. X cubed, he wants to party. Can he party right now? No. 8's got to come over. So it's x cubed plus 4x squared minus 2x minus 8 equals 0. Since there's 4 terms, there's no GCF. I'm going to have to do grouping. X squared, negative 2, negative 2. So it's x squared, x plus 4, minus 2, x plus 4. Combine the coefficients, x squared minus 2, x plus 4. Can I factor further? No. X squared minus 2 is almost dots, but 2 is not a perfect square. So I have x squared minus 2 equals 0. I have x plus 4 equals 0. The x plus 4 equals 0 is an easy solve, so I'm going to solve that. Done. The other one I'm going to kind of bring up over here. Since there's no b value, the easiest thing to do would be isolate square root. So I isolate the x squared, I take the square root. When you take the square root, it's plus or minus. Radical 2 is radical 2. Can I reduce radical 2? No. So my answers are plus or minus radical 2 and negative 4. Again, if you end up with just x squared and a number, isolate and square root is the easiest way to get those answers. And make sure when you're taking the square root, you put the plus or minus. There should be 3 answers. 1, 2, 3. All right, there's maybe 2 more that I want to go over with you. I definitely want to go over number 9, so let's go over number 9. Mr. X to the 4th. Since it's x to the 4th, there's going to be 4 answers. So he wants to party. Can he party right now? Yes. What do they want to do with the party? Bubbles, factoring. Since it's x to the 4th, it's going to have to factor. Again, I can only use quadratic formula, isolate square root, completing the square, if the highest exponent is x squared. I might have to use one of those methods later, but I'm going to have to factor first. So it's a trinomial. Because it's x to the 4th and x squared, it's x squared and x squared. First sign comes down, negative and negative to positive. What multiplies to 32? A lot of things multiply to 32. I guess not that many. And subtract to 4, 8 and 4. Can I factor further? No. The first one is almost dots, but it's not. The second one is almost dots, but it's not. 8's not a perfect square, and the x squared plus 4 is a plus, not a minus, so I can't factor further. So I set each factor equal to 0, and since both of these are just x squared and an integer, we can do the isolate square root method for each of them. So I want you to try that on your own right now. If you can pause and try to solve each of these on your own using the isolate square root method. Okay, you should have just unpaused. You should have just tried finishing this off on your own. For the one on the left, I'm going to isolate by adding 8 to both sides. Square root. When you take the square root, it's plus or minus. Now I can't take the square root of 8, but I can reduce it. 4 and 2. So x equals plus or minus 2 rad 2. That's 2 of the answers. For the one on the right, isolate, subtract 4, square root, x equals plus or minus the square root of negative 4. Well, I comes out because of the negative. Radical 4 is 2. So your 4 answers are positive 2i and negative 2i, and positive 2 rad 2 and negative 2 rad 2. I want to go over just maybe one more. Let's find a good one to go over, and then after that, you're going to have the rest of the block to practice, and you will have a 1-question quiz at the end. I don't want to do that one. Do I want to do this one? Yeah, this one's good. Mr. X cubed, he wants to party. Can he party right now? Nope, that 6x has to come over. So I have 3x cubed plus 12x squared plus 6x equals 0. Party time. What do they want to do with the party? Bubbles. Bubbles mathematically means factoring. What's the first thing we look for when we're factoring? GCF. Is there a GCF? Yes. 3x is my GCF. So I divide each of them by 3x. I get x squared plus 4x plus 2 equals 0. Can I factor further? Well, are there two numbers that multiply to 2 and add to 4? No. So I set each factor equal to 0. The one on the left is pretty easy to solve. X equals 0. And whenever there's a variable GCF, you're going to always get 0 as that answer. And on the x squared plus 4x plus 2 equals 0, since it's a quadratic equation which doesn't factor, I'm going to have to use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, when do we use that? If it's a quadratic equation, a quadratic with an x squared, that can't be factored. Now, yes, we didn't use quadratic formula for this one, for each of these that had an x squared and couldn't be factored. But since there was no b value, I could just do the isolate square root method. I could have done quadratic formula for these where b would be 0, but it's easier to do isolate square root method if there's no b value, if there's no x value. For this one, since there is an x value, I can't do isolate square root. I would have to do quadratic formula. I want you to take a couple minutes right now on your own, and I want you to solve this equation using the quadratic formula. So please pause and try to solve it on your own. Okay, now that you tried it on your own, let's see if you got it right. A is 1, B is 4, C is 2. So it's x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 2 all over 2 times 1. We go to our calculator, we type in what's inside the radical. Don't type the radical, just what's inside the radical. 4 squared minus 4 times 1 times 2. 8. Wrong button. Over 2. Now off to the side, I don't have a lot of space here. I'm going to reduce the radical. And again, this is where a lot of students get messed up. Once you get the radical, you need to reduce it. So I replace rad 8 with 2 rad 2. And then I reduce something that goes into all of them, if possible. I can take a 2 out of all of them. And I end up with negative 2 plus or minus rad 2 over 1. I don't have to put the over 1. Those are 2 answers. This is your third answer. There's 3 answers. That's it. So this takes practice. Utilize the key as you're going through it because it's a lot of computational stuff. But conceptually, to solve a polynomial equation, you bring everything to one side. You factor. If it is a quadratic and it doesn't factor, you can use the quadratic formula or isolate square root. Whatever the degree is, whatever the highest exponent, that's how many answers you're going to have. Again, here, if the highest exponent is 3, there's going to be a total of 3 answers. Keep in mind that plus or minus counts as 2. And that's it. This takes practice. Obviously, you have to know how to factor. You need to know how to do quadratic formula. So there's a lot of prerequisites for this lesson. If this is your first day and you're looking at this lesson, you are not going to be able to do it. Again, because there are a lot of prerequisites. There's factoring, there's quadratic formula, there's isolate square root, and there's also the reducing radicals, and there's a lot of prerequisites here that you need to be able to do. But if you have all those prerequisites, then hopefully practice will get you to where you need to be. And that's all I got for you. All right, you're going to practice the rest of the block, the rest of the period. We're going to spend 2 periods on this, and we're going to have a 1-question quiz at the end. Have a great day.